All right, speaking of garbage collection, indeed, this is chapter 12, I think.
It
The
is.
final chapter of Ruby under a microscope, garbage collection in MRI, JRuby, and Rubinius. So yeah, what are your takeaways? What are your thoughts here?
It was interesting to read the differences. I felt kind of disconnected to JRuby and Rubinius since we're not using it. And the memory group has done a lot of work with different tactics for garbage collection to reduce memory pressure. So
Sure.
we've been playing with JE and the Nakayoshi fork in Puma right now. So it was interesting to kind of think about the work we've been doing recently and understanding the underpinnings of garbage collection within Ruby, even through the different frameworks. And once again, there were some similarities to .NET with the way that they were talking about with JRuby and Rubinius doing the generational garbage collection. So, because that's the way
Yeah.
.NET does it.
Okay. Yeah, that's true. This definitely relates much more heavily to your day-to-day work dealing with memory management. That's what garbage collection is all about here. More than I guess it relates to my daily work. Although I did like the phrase, I think it was somewhere near the end, maybe in the summary, where it was talking about how garbage collection is a very important aspect of probably any programming language, but it's usually one of the least understood, sort of under-taught aspects of it, especially when you're like, you go to learn Ruby online, like they're not going to teach you garbage collection first. It's like, here's how to like write some code and make something work. So yeah, it was kind of, it was nice and eye-opening, I guess, from my perspective to understand that, the garbage collector isn't just like going through your program every now and then to like find things so they can reap, but it's actually the thing that is responsible for allocating the memory in the first place, which makes a lot of sense because then it knows where your memory is and what it's put in there, and then it can go through and kind of mark things as being used or not used and sweep it up. So yeah, that was really kind of something new that I learned, is that it does both those things, which makes a lot of sense. But
yeah, well, the JRuby and Rubinius garbage collection algorithms are much more elegant and scalable, it seems, than the MRI garbage collection. And they even called it out, right? MRI blocks execution. There's no, at least from what I recall, but there's no concept of concurrent, which JRuby and Rubinius had. And they even admitted that it's slow doing garbage collection. So it makes you wonder, like, do people really push Ruby to scale to the point where they'll see some of the bottlenecks at garbage collection? And if they do, is that the point where they jump to another language, or do they perhaps jump over to JRuby or Rubinius at that point in time? What's the failover point for people when they run into these garbage collections? Or do they even know that it's a garbage collection problem? Once they get to that level, they just see that Ruby is not working for them anymore and they need to move to whatever hot language is at the time.
Yeah, that's a fair point, because I feel like there have been a lot of, I don't know, naysayers, I suppose, of Ruby and Ruby on Rails for some of its performance aspects, and how much of that is, memory management of, let's say, how Rails is allocating things itself, which maybe a lot of developers can't directly influence, versus, I guess, how their code is managing memory on its own. And I think there was a point in here where it said, like, it's far better to try to fine tune the memory management of your application before you start worrying about increasing your memory size or trying to go concurrent or all these other things. Like, that if your application is just underperformant in how it deals with allocating, lots of objects, like you're probably in hot water no matter where you take it.
Yeah. There's going to be diminishing returns on throwing hardware at it, although often that's the cheapest way to go, right?
Yeah. It kind of reminded me of I think it was an issue maybe opened by Camille earlier this week or maybe last week, where he was looking at doing string concatenation. So there was lots of places in the code base where he found that somebody would have a string And then they would say, okay, now the string plus equals this other string versus saying this string dot concat other string, or a string, you know, is it double left bracket, left angle bracket,
Chevron.
other string, yeah, chevron type thing, yeah. And the memory management there, because in the plus equals, you're creating a brand new object every time. So you're taking an existing object, making a new object, and adding, you know, the two things together, maybe even making a third object, I don't know. But the memory allocation was like 10 times more or something for that approach. Like it just didn't even compare. Like the concatenation was just like, let's just add this, you know, add it directly into the existing object in memory versus allocating brand new memory and probably doing garbage collection and all this other stuff under the hood.
Interesting.
Yeah, let me see if I can find that.
That kind of makes sense to the, was it like 2 chapters ago, the copy on write? Because you're going to abandon the original object when you override it. And it seems like it would make sense in the concatenation case.
Yeah, and I just realized I'm not taking any notes.
The last one, nobody will notice.
Yeah, it's fine. So let's see. Chapter 11 and 12. Oh, they did 11 and 12 together. Interesting.
They just wanted to make sure they finished before we did.
Yeah, because this week, I guess they spent the time talking about what book they want to read next.
I saw that. Ooh. Talking about design patterns. That one could be painful if it's the old school one.
I think they
cool.
chose to go for 99 bottles of object-oriented programming by Sandy Metz. Yeah, so that's pretty exciting. I might sort of asynchronously follow along depending on what time their meeting's at.
Yeah.
Sort of read on my own and add my reflections to the agenda ahead of time or something, and read it later.
Oh, okay. I was looking for an issue. I didn't see.
Yeah, there may be an issue. I'm trying to remember if there's an actual issue we made out of that, but docs here. Add memory optimization docs. Oh, I guess he put it in docs through an AMER, not through an issue. So.
Interesting.
Yeah. Yeah, so let's see. The string plus equals ended up creating 1,003 memory objects and doing 1,000 memory allocations and doing, what is this, like 2 megabytes of memory? Whereas the string concat version had 3 memory objects, 1 memory allocation, and like 49K of memory. So it's like a huge difference. So yeah, it's pretty wild when you think about it. And that's only 1,000 times. Like that's not even, you know, 1,000,000 times. Like they were doing some, or what, 10 million times I think they did in this garbage collection chapter. They would do something for 10 million times just to see it. Yeah. So that's pretty significant. It kind of makes sense though. Is you did it 1,000 times and you know, did plus equals, so you got 1,000 new memory allocations. Yeah. But yeah, without reading this chapter, I wouldn't really understand, you know, I wouldn't have understood as well, I guess, like how easily that's, you know, that's adding a whole bunch of objects into the space that are currently like new referenced objects or whatever versus garbage collectible objects.
Yeah, especially the way Ruby allocates in the same size block every time, right? What was the number? 40 something?
Yeah, what was that number?
I think it was 40.
40 megs?
40.
Or
no, 40 bytes. We can just edit this part out and make us sound smart.
Again, no one's watching this, so it's fine. Oh, man. Let's see, total 17,491. What is that? Is that kilobytes, bytes?
Our value seems to be a 40 byte Ruby object. Yeah, so 40 bytes.
So each block is 40 bytes, is that?
Yeah.
Okay. Yeah, that was interesting when we kind of got to the JRuby and Rubinius section and this bump allocation, which I thought like that seems really smart. Like just allocate exactly how much you need and you keep all of your sort of memory pointers for a specific area of your code all together so they can be cached at the CPU layer.
Yeah.
Which, you know, is well beyond my understanding of how things work. But the idea that like, okay, we can cache all these things together, which makes it faster to read them when we're accessing the same areas of code, like this makes sense to me. Versus like the other way, the sort of, what is it, mark and sweep methodology, where it's just like, you know, you sort of reuse different random spots of your memory over time and stuff's all over the place.
Yeah.
One thing I didn't quite fully understand was when we started talking about the Eden heap. I don't quite understand what that is or how that works. And then this idea of the sort of longer lived objects, the generational type garbage collection. So we have these survivor spaces, which the whole sort of, you know, memory allocation and memory swap and heap and like this is all way deeper than I know of anything. So it's kind of just like messing with my mind in general. But yeah, the idea of like the sort of young objects and mature objects, and then I think JVM even had this like permanent type space where it said like these objects are just going to live forever.
Yeah.
And how that promotion process works, and like, does that mean that then there's essentially 3 or 4 or 5 different segments of memory allocation all going on together?
Yeah.
And I don't know, like, yeah, how does that all play out with overall memory usage, I guess?
Yeah, I didn't read too much into that. I think I was blasting through that part thinking, all right, I'm not going to get too far into any of this because we're not going to use any of this, right? We're not using
this, yeah.
JRuby or Rubinius, and it's more of a to use computer science nomenclature. I have a pointer where I can go look this up later on if I need to, but for now, it was an interesting read, but I didn't get too far into the why.
Yeah, so they do talk about how from Ruby 2 moving forward, they're using more generational concurrent garbage collection stuff in MRI, which is nice. So maybe it is becoming more relevant. I was kind of curious about that as well. Like, since we're now entering the realm of Ruby 3.0, like how much farther have we progressed in what garbage collection looks like in MRI?
Interesting.
Yeah,
I'm sure there's a study out there somewhere. It wasn't included on this one.
Yeah, no doubt.
I didn't really have anything more.
Yeah.
But it was an interesting book. Very, very deep.
Yeah, very deep. Deeper than most things that I'll ever use or think about in general day-to-day.
Did you pick this one or was this a group?
Nicholas, so one of my colleagues in growth, Nicholas Dular, he suggested it, and I don't know, it sounded like somebody suggested it to him, or he just thought it'd be a good idea to, like, in somebody else's thread about what books to read, and thought this would be a good one to have a book club around.
Yeah.
So yeah, so he's kind of been spearheading the Europe, the EMEA time zone version of this. So yeah, they're moving on to 99 bottles of OOP. I don't know when they're starting that. Maybe they'll just keep going at the same cadence, but yeah, that's where it's going. And thanks for joining this.
Absolutely. Yeah.
Yeah.
I'm glad the timeline was reset a little bit so I could actually join, because I felt bad when I bailed out early on. So
it's nice to have a participant. It's otherwise it's just me talking to myself. It's not
we had multiple participants most of the time.
We did. So. Yeah. There was only, I think, maybe 2 where no one showed up. So Yeah.
Did you like dual record yourself so it looked like you were talking to yourself?
You'll have to troll around YouTube to find out, I guess.
All right, man. Well, thanks for setting this up and moderating.
Yeah. Easy peasy.
Nope. Catch you on the next one.
All right. Catch you later, Craig.
2000.
Bye.